Okay, so we have this little model of communicable disease transmission, and it's kind of minimal in its simplicity. There's a lot of things that could at least be desired in terms of something a little bit more textured, and I think I'm going to add in 2 or 3 of them just to sort of flesh it out a bit and make it less austere, make it less almost sparsimonious, merely make it parsimonious. Sure. Okay, there's a question for sensitivity analysis. I'd be glad to do that. Yeah. Now I'll weave that in. Thank you, Salah. Absolutely. Okay, so one thing I want to do is I wanted some mechanism of providing you access to statistics, and sort of reporting on what's going on in this model, having some record of how many people are infectious and recovered, et cetera, over time. Another thing I want to do is to clue you into a bit of best practices, and I told you I felt guilty, and not quite racked by guilt, but I feel guilty for sort of teaching a bad practice there, and I want to remedy that, if only to sleep better at night. Thirdly, and along best practices, I want to show you another little best practice along the way that's more aesthetic than anything else, but communicates intentions. And I'll do the sensitivity analysis thing. I like that. Maybe I'll, in the process, deal with reporting that's often a need at a practical level. So it's I risk by doing this of not having proper time to do another model, but I think these things are important. So I'm just going to undertake them. So first, let me show you. Let's sort of make this a little bit less sparsimonious. Let's make it merely parsimonious. Well, right now, infection is certain, and I want to teach you at least about how to make these transitions less certain, both because transitions between states, this is often a need, but also because we will often use a similar mechanism to divide people up when they enter the state chart amongst different states. So I'm going to go up here and I'm going to pull this back like that. Not a pull back in a categorical sense, but it's a good thing. Okay, so I put in a branch here. Boom. And a branch represents, well, a logical, either or sort of option, or it has to decide between two options, or go one way or another way. And I'm going to stick in from the branch an outcome and a default. Here we go. Now, when you build a branch, you can have 2 or more outcomes. You can probably have 1 or more. Yeah, but generally you have 2 or more, because you're choosing between different options or selecting between different options. So one of them will be the default, and the others will be alternatives. So here, we called this infection, and this is no longer infection. I'm now this is exposure, and I'm tempted to call this exposure as well, and now I'm so I think I'm going to call this this one instead transmission. I don't like it because it's not guaranteed transmission, but it is the mechanism through which transmission occurs. And this one will be called exposure. I like that more. And this one will be called infection. It's only if they go this way, that'll be called infection. And this one, well, we won't even give it a name upon the world. So we'll leave it like the horse with no name, without a name. Okay. So this will be not the default. This will be a conditional. We can only have one default coming out of things. This will be the default. They ain't infected. It's only if they're unlucky on transmission that they'll become infected. So if they're susceptible, they'll have a certain chance of getting infected with a certain probability. And we'll see how that occurs. And I want to teach you that mechanism. Okay, great. So this is the basic structure. Because it's getting a bit crowded, I'm going to move this up a little bit and give it a bit of legroom. There we go. By the way, you can click on these things if you're kind of inclined towards prettifying it, and I'd encourage you. You can click on them and put on handles. Oh, come on, don't tell me. That's so why isn't it? There it is. Okay. And you can kind of stretch them as you see fit. You can put on more than one handle and bend it like a pretzel if you want. But in general, you can move these things around with these handles. Okay, so what we're going to do is we're going to go to main, and we're going to add in a transmission probability per discordant contact. Yeah, I know. I like to be verbose. My category theory colleagues don't like it, but that's the way the cookie crumbles. So here we go. So this is going to be called transmission probability per discordant contact. Okay. And I'm going to make it 10%. Now, if we had the whole night, or if we had till midnight, I would start putting in mask use. Oh man, it would just be beautiful. Beautiful. You would change the transmission probability discordant. You'd have one for with mask use, one for without. And based on the person's mask use, you'd use one or the other. Oh man, I could do that. Oh, that would be just gorgeous. I'm tempted to do that, but one step at a time. Just have one transmission probability per discordant contact. Maybe we'll make it, maybe we'll make it more than this by default. We're kind of imagining the maskless case. Maybe it's 0.25. I don't know. 1 out of 4. Transmission probability per discordant contact, 0.25. This is in main because we want one for all people. Back to person. Okay. So when they come in here, by discordant contact, I mean a contact between a susceptible and infective. So when that exposure message comes in, move this around, they're going to, the probability they'll get infected is given by exactly that parameter we just said, transmission per discordant contact. Okay, so their chance of going down here, will be given by random true. So we have to give a true or false here. It's only if it's true that the condition has to be true for them to go down here. So it'll be true with a certain probability. That's what random true is. If I said 0.1, 0.2, 0.3, it would, if I said 0.3, it would be, they'd go down, it would flip a coin with 30% chance it would go down here. kind of a weighted coin. If I said 0.5, it would be like a perfect, fair coin. If I said 0.1, it would be like, going down here with a 10% probability. If I said 0.166, it'd be like rolling a 6-sided die. Okay, so random true, it returns true or false. I mean, you can look it up. You don't have to have me. It says generates true with the probability P. Okay, and it's equivalent to drawing from a uniform value between 0 and 1 and asking if it's less than P. Okay, so random true, and guess what? The probability they get infected per exposure, so per discordant contact. Obviously, it was someone who exposed them who was infected, and it's susceptible. So per discordant contact, the transmission probability is given by what? Who can tell me what to type here? What is it?
It's main dot.
Yes, you got it. Main dot, and it's this long, horrible thing, right?
Yeah.
But you just press control space and the life is good. And yeah. That doesn't happen in category here. So yeah, you press control space and it fills it up. And that's why it doesn't hurt much. Okay. So this is what you get, okay? And so with the 10% probability or whatever it is, they'll go down here. Otherwise, they'll go back to the state. That's the default. So that the default. Go back there. With this probability as given by this thing, they'll go from here to here. So if this thing were 0.1 with 10% probability, they'll go down here. If this thing were 0.5, this whole thing were 0.5, they would go down here with the coin flip, right? Only if it was, the loony was up, the beak was up, would they go down here, right? Okay. Yeah. If this thing were 1, they definitely go down here on exposure. Okay. I'm going to run this model, and you're going to tell me what's wrong. So I'm going to run it. By the way, I build early, build often. I built it. It's fine. Happy. Okay. And now I'm going to run it. Let's see how the network, how the infection spreads. Oh, it's not spreading. It's not spreading. Well, maybe we infected one of these folks, but I don't see it. Okay, let's try it again. Ready? Let's try this. I don't see it. Well, let's go see what happens. Okay, so someone was infected originally, but they didn't pass it on. Oh, okay, let's go see what happened. Huh? Okay. But you notice something is odd here. Okay, so it's their annual income 116,000. Some of that looks familiar. 116,000. Oh, huh? It looks like 116,000. Oh, it's like the same person. But why is it the same person? It should be, oh my gosh, this looks like the same network. The same stinking network every time. Look at that. It's the same network. It's like Groundhog Day. It's just same thing. What's going on here? Well, in any logic, you got to be careful about this because by default, it uses a fixed seed. It's using the same seed every time to run this. It's not doing them randomly. It's doing it with the same thing every stinking time. It's doing the same random number sequence. So generally, you don't want that. I think they changed that to be fixed seed at some point, and it causes modelers grief. Now we got a different network. Let's see if it spreads. Well, we got an annual income of 0.1, but wait a minute, where is this? Where's this message? It's here. Is that true that they were infected? If they go across here, is that true that they're infected? Is it true they're going to go on to the exposed state? If they go here, are they definitely going to go on to this state? Yes or no?
Nope.
No, it's only with this probability. So really, we left this here and we were careless. Really, this should be moved here. That's where it belongs. In its rightful place. It's assumed its rightful place. Now let's suppose if we run it. What's going on here? Well, let's go look at the console. Nobody is reported as infected. Let's run it again. Different network, nobody infected. Let's run it again. Different network. Oh, this time someone was infected. Okay. I hate to say that's good if someone's infected, but at least something happened in our model. Okay, so it's not like it never works. What's going on here? Okay. So this time someone was infected too. Maybe they're way out there or something. Okay, I don't see them, but okay. Okay, now wait a minute. Okay, so yeah, okay. So that time they were infected too. Okay. So it looks like sometimes it's infected and sometimes not. It looks like it isn't always spreading. This time it spread only for a couple. There it is. No, now it's spreading. Okay. Well, the initial infection also goes down through here. Remember that? It's coming through this place. And so maybe the initial infection message a lot of the time never reaches it doesn't infect the original. We intended it to infect that person. After all, the very name of this is initial infection event. It doesn't say initial exposure event. You want to infect them, but you're only doing it with this transmission probability. You're only doing it with that transmission probability. So we need a way of, if we're going to use this mechanism to kind of expose someone and start them infected, we want to do it with a clear transmission probability. Sorry, I want to do it for sure that they're infected for the initial person. Okay. Kind of an annoyance. It's kind of a little detail. Yeah, okay, fine. So how we're going to do that? Well, we're going to differentiate the initial infection, the force infection event, from any old infection. And I'm going to show you the best practice, ladies and gentlemen, a best practice. And I'm going to show you two best practices. You're going to buy one, get one free. Okay, here we go. Mark my words. Watch this. Okay. Okay, so first of all, this thing is for the birds. This whole thing about where we're sending this thing. I mean, yeah, we could do it if there's only one sort of message. It's not bad. You just have them handling it unconditionally. But now we need two messages. One that will for sure infect them, and one that will infect them only with a certain probability. So we're gonna, first of all, we're gonna add this one. We're gonna call it force infection. It's gonna be like the initial one. It's gonna force them to be infected. Here we go. Force initial infection. Again, this isn't the only way you want to do it, but I'm showing its logical conclusion. Force initial infection. And what sort of event is this going to be? Anyone going to say? It's going to be a message transition. It too will be a message transition. Now we have two types. This will need to be different from that. And this is the way you do it nicely. This is the way you do it sweetly. This is the way you do it beautifully. This is the way you do it properly. Okay, here we go. Okay, so go back to your projects, and I'm going to introduce you, ladies and gentlemen, to a delightful member of the AnyLogic palette ecosystem, and it's called Actually, it's not in the palette. Any logic ecosystem, model ecosystem. It's called an option list. And it's going to be called messages. We're going to create so a message list lets you list out things. You might use it for male, female. You might use it for the provinces of Canada, British Columbia, Alberta, Saskatchewan, etc. Provinces and territories. But here we'll use it to list messages, okay? And I'm going to say messages, and there'll be two messages. One is force infection message, and another will be exposure message. By the way, you could have flu exposure message, COVID-19 exposure message, RSV exposure message. Okay, I'm going to say finish. There we go. There are our messages. There they are, arrayed before us with proper dignity. Okay, great. So now we have two different messages. And these things, if you misspell them, it'll have a fit, which is great because you wanted to check, did you spell it correctly? If it's just a thing in quotes, it has no idea if you spelt it correctly, and will allow you to misspell it without even flagging it, without blinking a silicon eye. So these ones, it'll more than blink a silicon eye, it'll flag you down. Okay, so this one will be based on a particular message. And what message will that? It's not any stinking quoted thing which could be misspelled. No, that's for the birds. No, it'll be called force infection. Now, you could try to do this, and you will find it's there. You could also say messages dot force infection if you want to. Force infection message. If they get a force infection message, they're going this way no matter what you try to do, partner. It's coming down here. This one here, this here one, is based on a particular message. And what message is it? It's exposure message. Yeah. Okay, now we've differentiated. And what's the other part of this? Who sends these messages? Where is the exposure message need to be sent? Can anyone say?
From that transition within the infectious state.
Darn right.
Oh yeah, transmission it's called.
Transmission indeed. So this one is called, you got it. You're getting it for sure. Congratulations. So this one is called exposure message. That's going to lead them to a situation where they may or may not get infected. It's a plain old exposure. Plain old simple exposure. It exposes them and they may or may not get affected. This one is going to be sent by where? The force infection message needs to be sent by, it's the very first one sent in the model. We want to guarantee someone starts exposed. So we're going to send that from the get-go. We're not going to have it just, a quarter of the time it actually catches. No. We want it every time to infect at least one, to infect one person. So this gets set, this force of infection message, force infection message is sent here. Instead of sending exposed, we send force infection message. Okay, now you may wonder why I make such a song and dance about this. But the point is, again, if I misspelled this, if I did it with a lowercase f, it would throw a fit. It'd say, I don't know what you mean. And it forces it to be totally consistent between the name here and the name here. And it avoids you misspelling it or forgetting an exclamation point and putting it lowercase rather than uppercase, and generally getting in the way of its kind of persnickety sort of preferences. So here we go. Now it's a thing of beauty and perhaps a joy forever. And so if we run it here, we will see, okay, it got infected. Yeah. So we know at least one person starts honest to goodness infected before a lot of the time it was falling on stony ground. You cast out this message and it didn't catch. It was like the proverbial match that fell on a damp piece of wood, and it never caught. Now it's catching for sure. That bit of kindling is catching. And so we've got at least one burn. Okay, so there we are. It's catching. There we go. There we go. Okay, awesome. So that's those are some best practices. I wanted to teach you about option lists, which are generally very good, including for drawing from custom distributions and encoding things like people's ethnicity or province of origin, and all these things where we have different categorical possibilities. And we want to give them clear names and refer to those names in code, male, female, etc. Great. Version 6 is on its way in just a moment to be posted. But we're gonna go do better than this. Version 6, ladies and gentlemen, is posted. Okay. Next, maybe I'll record this.